Okay, a video for those of you who have missed classes on improper integrals. Here's an integral, 1 to infinity of dx over root x. But the infinity makes it improper. So the way I have to do these is I set it up as a limit, letting b, which is some number, go to infinity of 1 to b, x to the negative 1/2. Then I evaluate this definite integral like I normally would. The antiderivative is 2x to the 1/2 from 1 to b gives me 2b to the 1/2 minus 2. Now I evaluate the limit, and as b goes to infinity, this term goes to infinity. Therefore, we say this integral diverges. Similarly, here in number 3, I got 1 to infinity of dx over the 4th root of x. So I set it up as limit b goes to infinity of 1 to b of x to the minus 1/4. Evaluate this out, and it also goes to infinity, so it diverges. Now hold on a second, because on the second page there's a much more important one where in this, I have the integral going from 0 to 2 of dx over 1 minus x squared. But this has an infinite discontinuity or an asymptote at x equals 1, so therefore it's improper. And since it's in the middle of the interval, I need to set up 2 integrals. One going from 0 to b as b approaches 1 from the minus side of the integrand. And then the second one from b to 2 as b approaches 1 from the plus side. If you look, this covers that interval 0 to 2, but I replace 1 with b here and 1 with b here. Now this is a little complicated. I'm not going to go through all the work, but you have to do the antiderivative using partial fractions. So in the end, you're going to end up with this. Look at the left integral. Limit as b goes to 1 from the negative side of 1/2 ln of 1 plus x minus ln of 1 minus x. That came from the partial fractions. But when you go to evaluate this, do you see you're going to have ln of 1 plus b minus ln of 1 minus b. But as b approaches 1, this term, do you see it? It's going to approach ln of 0, which you need to know in ln of x that as ln of x goes to 0, as x goes to 0, ln of x goes to negative infinity. So this integral, just this one here, is going to diverge. Doesn't matter what happens with this one now, because if one of the two integrals diverges, the whole integral diverges. So I'm sure you'll have questions on this one, but it's important to understand how ln works. I wanted to show you one more where this is on the homework problem sheet that I sent to you. So it was from negative infinity to infinity of e to the x, but since I have improper integral, I have to set up 2 integrals here. I'm going to say the first one, let b approach negative infinity, put my b to here, and go to 0. And then on this one, I'm going to go from 0 to b with b approaching infinity. So if you see, these 2 integrals essentially map this one. So now I can evaluate this one easy. The antiderivative of e to the x is e to the x from 0 to b. So I get e to the 0 or 1 minus e to the b. As b approaches negative infinity, you should see this will go to 0. So this integral on the left converges to 1. But then when we go to the right, we have the limit as b goes to infinity from 0 to b of e to the x. The antiderivative is e to the x, and then evaluated at b and 0, I get e to the b minus 1. But b is going to infinity, therefore this is going to infinity, so this integral diverges. So This one diverges, this one converges, but if either one of them diverge, the whole integral diverges. All right, 5 minutes and 7 seconds. I hope you can endure it.